Hello and welcome back. In this video, we are going to implement a regular expression matching. First, let's go through the problem statement. Here we have uh, regular expression matching, and the problem statement reads as, given an input string and a pattern, implement regular expression matching with support for dot and then asterisk, where dot means it matches any single character, and then asterisk means matches 0 or more of the preceding element. And we have some additional information here, that is an input string can be uh, empty, uh, so the implementation has to take care of that, and then it can contain only lower cases like it is z, uh, and also a pattern can be empty, right? So there is basically nothing to match, or can contain only lower cases, etc. Or it itself can contain characters like dot and asterisk. Okay, because dot and asterisk have meaning. We're going to implement dot and asterisk. They have a semantic associated with them. So the sample input we have here, one simple one, yes is equal to bb, this input is string, and then the pattern is b. So it's certainly a match because there are two matches. Pattern is b. Output should be uh, b does not match the entire substring. Well, that's interesting actually. Uh, okay, we'll see this one. Let's see the second one actually. Um, Input string is Massachusetts, and then we have a pattern p mas asterisk, uh, and then we have a and then asterisk and then dot and asterisk. So this means first we should see mas, that's mandatory, and then there could be any number of as. Okay, and after that any number of as occurrence, there should be a, and then there could be any number of a, and then any character, and it could come any number of times. So basically mass with yes any number of time followed by 0 or more a followed by any number of characters. So that looks like a match, but we'll see all of these things here. We will see we'll implement the program, and then we will see whether it does match or not. But the second one is certainly a match, no doubt on that. Okay. So the first one, if we see only b occurs there, b has, it's a substring of bb, but the b itself, if we say whether b is in bb, but whether the whole thing it actually matches with bb, it doesn't match, right? But the b is in it's a substring of it, but the pattern does not specify the string bb. But if I say b star, this actually specifies that string, so that's why. Okay, now let's go to our implementation and do first the Java implementation. Okay, starting with our um, file name, regular expression match. Let's also do this line number. We like line numbers. All right, that's our regular exp match. So basically in this implementation, what we are doing is, in many programming languages we have a support for regular expression, and regular expression is one of the most powerful language feature available in any high-level programming language, because when you have a problem with any implementation, we can go down to character by character representation, because that's the ultimate as far as as far as high-level programming related interpretation is concerned. If you're not doing 1010 kind of analysis, the machine code level analysis, the next lowest possible analysis is in terms of high-level programming language regular expression, because if you go beyond that, we are going to 101010, which is certainly very time consuming to analyze. So that's why regular expressions are one of the most powerful features of any high level programming languages. And then in this uh, session, what we are going to do is we're going to implement API, a feature in pretty much this can be used in a programming language to provide a feature, language feature, to determine whether the pattern actually matches with a given string, or the pattern actually can describe the given string. Okay, so it's a very interesting implementation. This is going to be useful even if you are doing application development for any kind of commercial or customer implementation, or even if you are doing a programming language implementation, that's still going to be useful. So it's very useful, very powerful thing. So Simpleman is very fun, very interesting, and also easy. Okay, so I think we have one extra yes there. All right, so as usual, we're going to have our signature for our main method. Okay, we'll come back here because first we want to implement our main logic, and then obviously it's easy to write the main. So our main, we're going to do private static as well, and we're going to return the true or false, whether it matches or not. Okay, and we're going to pass two strings. One is the given text and the other is actually the pattern. Okay, and yeah, okay, now here we're going to implement. All right, so first thing what we're going to do is we're going to create an array, two-dimensional array, and then this is going to be initialized with default value, and then the length would be calculated based on the length of the you could say in the row we'll have as many rows as the length of the text, given text, and then in the column we'll have as many rows, sorry, as many columns, as many number of columns, as many number of columns as many as as many as the length of the pattern. Okay, let's just write it, it'll be clear. Boolean two-dimensional. Okay, I'm just going to call it storage. Okay, actually we're going to use some techniques from dynamic programming. New Boolean. Okay, so my first dimension is text dot, that's what I was trying to describe. Probably I didn't succeed very well. Length. Okay, we're going to do +1 here, and we'll tell okay +1 because we'd like to have 0 to, if the length of the text is 5, we'd like to have 0 to 1, 0 to 5, and then we have to do 1 because the index starts from 0, 0, 1, 2. If I don't do 1, then it will go up to 4. 0 to 4 is 5. That's the length of the string, right? So I need to do, if I want to have an index, 5th index, then I need to do +1. Okay, and we're going to do the same thing for the second dimension, which is pattern dot length, and that also +1. Okay, so we describe two dimensions. That's it. And next thing is, since the last one is something that's our initial, in the 5th position, that's our something to get started with, and we're going to set that to true. Okay, so text dot length. Okay, and then this one pattern dot length. Okay, if it's a 5, we're going to 5. That's our last index. This one, and we're going to set that to true. We start with that. Now we will have two embedded loops. That's where we got our well, I think I forgot to talk about complexity. The time complexity is going to be, our implementation is going to be order of mn, where a m is the length of the text and n is the length of the pattern. And we end up with this kind of time complexity because we'll see in that embedded loop, it will run those many number of times. Okay, so that's where it's coming from, and it runs that embedded loop runs only once. So well, let me put it this way. But if you have a loop, it runs multiple times, obviously, but you know, the entire thing runs once, so you don't have more. We don't have additional complexity. We only have m times n complexity. Okay, I think that's better that way. And space complexity that comes from our caching. We store that basically. If we see the declaration here, the boolean, the two-dimensional declaration, so we're getting text length and then the pattern length in line number 7. So that's where it's coming from. So that is determined by the length of the text and length of the pattern. So we have time space complexity of order of m and n, and time complexity that comes from that loop actually. Okay, so I think that's pretty much clear, I think. Okay, for int I is equal to, okay, external loop is going to be the text length. Okay, text length. Okay, we're starting from the like right hand side. Okay, and we go up to 0, 0, and obviously we have to decrease the counter, and we have one more. The inner loop is going to be j, which comes from pattern dot length, but pattern we need to start from its exact value actually. Can go to the last one, right? So we need to start from here, and then this one comes same thing. We can go beyond 0, and of course we need to decrease it because we started from the higher index, I mean the last value. Thinking in terms of length. Now first we need to first do the first match, because first here in pattern matching, the first match determines other things, whether you have to do further matching or not. If there is no first match, then basically you have to move on to the next character in the text and see whether that matches, right? So you have to basically, if you're coming from the right hand side, probably we're decreasing. If you're coming from the left hand side, we're increasing. Okay, so here is the thing. Boolean first match is equal to it has to satisfy something, that is when you are iterating, I should be less than text length. Okay, that's one check actually, and then there are a couple of things. Okay, one is pattern pattern the extra character at I, that character, this is our check, pattern is equal to okay, pattern character, this should be j actually, because our inner loop refers to the pattern, and then outer loop is, that should match with the text. That's what we're checking here. Char at, and outer loop is I. Okay, either it should match with the, either pattern's character should match with the text character, or patterns that character could be just dot, you know, dot at say it could be just a dot, right? And that could mean any character. Okay, that's the first match. Okay, either it's matching with a character, or if I say a pattern has dot, then it will say any character. But a pattern in its first character, it can have asterisk, because asterisk should be followed. It should follow some other characters because it's a 0 or more those many times, right? But dot means any character. All right, that's the first match. Now we will make use of that first match. How do you do that? Next is if j plus 1 is less than pattern length. Okay. Okay. Remember, we are when you're doing j plus 1, we're going back and checking something from one step back, actually, that we covered, because since we are starting from the right hand side, the length, if we are decreasing, anything added it goes back. Okay, so over here if j plus 1 is less than, checking the pattern length. Okay, and we are covering a multiple occurrence of the character. Okay, j plus 1. Okay, that's previous character is equal to asterisk. Okay, if that is the case, we're going to do something. Okay, else we're going to do something there. Okay, what we're going to do, if it's asterisk, that means this is, we're checking a multiple occurrence. Is a multiple occurrence. Here is our in store ij in our current box, two-dimensional array. We're going to store I. We're basically going to get something from previous iteration. Okay, and that's two step back actually. Okay, this one, it could be that, or it could be first match and with, okay, it's a combination, first match and store one step back in the, two step back in the pattern, or one step back in the text. Okay, because the index, even though we have store this one, basically that is referring to either text or is referring to the pattern. I mean this movement basically. Okay, so store I plus 1. Yeah, store I say is equal to store I so plus 2, or cross match and store one step back in text and current index of the pattern. Okay, else we're going to change this. We're going to get the value, the boolean value for this one, the current box in two-dimensional array. That'll be the AND of first match and store. Okay, both one step back. Okay, just one step back for both, not two, like in previous inside if here, line number 13. I plus 1, j plus 1. Okay, let's do that. Then that completes our main logic. And let's see, this is the for loop, and just outside for loop, once we are done with the calculation, since we came from right hand side, if we visualize the two-dimensional array, you see that embedded for loop, j also started from the length and I also started from the length, the highest index. So when we are done, it comes all the way to initial stage. So, and we return that one, whatever is that one, because we're matching from behind, match, and we come this one. Okay, right. So why do we match from the behind? Is in matching, if the last character is a good test is not the first character, because if you match from with the first character, then we need to, if it's a match, we need to match the second character. If it's not a match, if first character is not a match, probably that's a good one. But it could be the case that the last character is not a match, and that is not a match. The whole thing is not a match, but we end up matching and testing all other characters. But if you do it from the right hand side, if the last is not a match, that qualifies it not to be a match, right? And you don't have to do all the testing, so you're saving. It's more efficient actually. Okay, all right, so that's the implementation here written, and then that's the end of this method over here, this one, and that's the end of the class. All right, we are now ready to implement our main method, which is also easy, and that method is, all right, I just need to do a few things. Okay, that's the regular stuff. I define my text, I define my pattern, and then I call the method to do match and store that in, let's say, my result, and then I print that because we want to test it, right? So I'm just doing a unit testing here. String my text is equal to, let's have Masha MSSA Massachusetts. Massachusetts. Is that the right spelling? String my pattern. So I'm trying to describe a valid pattern to it. Okay, I'm going to say I'm going to say MAS. Okay, I'm telling first three character must be MAS, and after that the well, I'm not telling that. First two characters should be MA, but yes, this is star followed, yes followed by star means 0 or more S after MA. Okay, that is still valid. And then that should be followed by A, there we see A there. Okay, and A can be 0 or more. I'm going to just tell that. It has to be exactly 1, but if I still 0 or 1, that's still a match that gives a valid condition. And then after that, I'll sell any character any number of times. Okay, that still is a valid, that describe Massachusetts. There are other ways of describing it, but this is one of the ways. Okay, that's what I'm thinking right now, but we'll test it. Boolean I result is equal to well, I think we need to be pretty sure whether before, because we're testing our program, but so we should be sure about our test condition. So I'll analyze it one more time and make sure that it is, I cannot be in doubt, because this is, our test should be stronger than our program. Okay, until everything is tested in the program. After that, I can rely with my program and take help of my program, but initially I cannot. Okay, let's analyze one more time. I was telling is first character should be MA. After that, any number of yes. Okay, it can be 0 number of yes, can be 2, it can be 5, right? So that still covers it. There are 2, and then after that we want A. That should be A 0 or more. Okay, so that is 0 or more, and then after that it could be any character coming in any sequence 0 or more times. Okay, so that covers the last one. So it should come true. Okay, you have programmed for everything, no error, it come true, but we have to compile and fix errors before we can do this one. Right, look at that, line number 23, line number 23, store. Okay, I forgot return. Okay, we're doing one more time. This time incompatible type char and string. That is right. That is absolutely right. Okay, it has to be character, and if we have other stuffs here, we will list it. Okay, dot is already a character there in over there. All right, we're going to compile. Very good, and we're expecting true. We are expecting true. Fantastic. Okay, so this completes our implementation of regular expression matching for dot and asterisk in Java. In the next video, we will see Python implementation.